Hello and welcome to video number 7 in our series of evolving network configuration videos. My name's Kevin Large and I'll be your instructor for this session. Okay, in video number 7 we're going to look at voice over IP or IP telephony. We're going to use Packet Tracer to design a little voice network. In fact, what we're going to do is we're going to adapt our existing network that we ended up with at the end of Lab 6, the Remote Access VPN lab. We'll adapt that network to use voice over IP. We're going to try to use best practice, so we're going to configure a separate voice VLAN to keep the voice traffic separate from the data traffic. On the router that's controlling the voice over IP phones, we'll configure a sub-interface for the voice subnet that belongs to the voice VLAN. We'll configure a DHCP pool for the IP phones, and then we'll get onto the really interesting stuff, which is configuring telephony service. Now, I'm going to configure telephony service in a certain order and in a specific way because it's just less painful that way. You'll see what I mean when I actually get into the configuration. Okay, but just to let you know, in the Cisco world, the voice over IP phones, you don't really do very much configuration at all on the phone, in fact virtually nothing. All the configuration goes on the router that controls the phones. The phones themselves are known as ePhones or electronic phones. We also have ePhone DNs, and an ePhone DN is an ePhone dialed number or directory number. To be precise, it's actually the phone number, it's the extension. Okay, and what you do is you create the ePhone DN, you set up the phone, and then you apply the ePhone DN or the number to a button on the phone. The phones we'll be using will be Cisco 7960s, which actually have 6 buttons because they can effectively have 6 lines, but we will only be putting one line or one number on each phone. Okay, again, this will make a lot more sense when you actually see it configured live. Now, before we begin, if you've been following through in these Packet Tracer labs, the very first lab, devices and connections, nice and straightforward, how to set the devices up and connect them together. We've got lab 2 with the trunk links, VTP, VLANs and sub-interfaces, lab 3 with the IP addressing. But the key thing to realise here is you only really need to work your way through to the end of lab 3, the IP addressing lab, and then you can do this voice lab. You don't actually need to have done lab 4, 5 and 6 in order to do the voice over IP lab. You could actually configure it on the network you generate at the end of lab 3. That said, I'm going to assume that you've worked your way through all of the labs and you've ended up with a remote access VPN lab, and I'm going to configure the voice on the network generated at the end of the remote access VPN lab. But it should work fine if you want to skip a few steps and just configure up to the end of lab 3. Okay, so moving forward, bring up the Packet Tracer network, and we have quite a complicated network now. We've got a LAN, we've got a corporate intranet, we've got the internet off out the top right hand side there. We've got a remote office off on the top left hand side where their work are coming in through a remote access VPN, and the next step will be to create voice over IP phones. So what we'll do is we'll actually put 3 phones on the network first, just to remind us what the aim of the job is. So phones are under end devices, and the 5th icon along from the left hand side we've got IP phone. I'll just drop these onto the diagram so as I remember what the purpose of the whole thing is, and then we'll need to do a little bit of designing. So what extensions would we like for our phones? Well, let's say that this phone over here can be extension 2001. Okay, looks good. Let's put it a little bit more accurately. Okay, and this phone here in VLAN 20 can be extension 2002. I think you get the numbering scheme now. Okay. And finally, in the management VLAN, we'll have extension 2003. So these are our extensions or our directory numbers, and this would be what goes on the ePhone DN, is the extension number. Okay, I'm not going to wire the phones up for the moment, and there's a very good reason for that, because the phones tend to go off and try to automatically configure themselves with things as you're actually trying to configure the router. You get part way through and you get numbers on here, and they can end up configuring the wrong number on the wrong phone. It's actually the number is tied to the ePhone DN, but the ePhone DN is tied to the ePhone through the button command, and the ePhone is tied to the the router via the MAC address on the phone, and it can get a bit complicated. What I found is the easiest way to do it is actually just to wire up the phones at the end. So let's see what we can sort out. First things first, we need to make sure that we've got a separate voice VLAN and a separate voice subnet. So let's think about subnets. Okay, so as per usual, VLANs and subnets, one subnet per VLAN, one VLAN per subnet, they're tied in together. So we will say VLAN 100. As you know, a VLAN is a broadcast domain limitation, so is a subnet. So we'll say VLAN 100. Your default gateway will be, let's put it on a completely different IP address range. The IP address range we'll use will be 192.168.54.0 with a /23 mask. That big /23 mask will give us, let's see, 32 minus 23 is 9. 2 to the power 9 is 512. Subtract the network and broadcast, it will give us 510 addresses, minus the default gateway, 509 addresses, so I could have over 500 phones with a /23 mask. That's the network address. Of course, the default gateway, we will make the highest IP address on the subnet. So that wode be 192.168.55.254. Okay, because that's a quite big subnet. It's effectively 2 Class C blocks worth of subnet mask there. Okay, if you're not too good with your IP addressing, I'm producing some IP addressing videos also, which will be up on YouTube. I think the first 2 probably up already while I was making this video, but they'll be joined by further ones soon. So we've got VLAN 100, your default gateway is 192.168.55.254, and that will go on sub-interface fast Ethernet 00100 on the router. Because this router is effectively doing router on a stick. Okay, but first things first, let's create the VLAN. Now the left hand switch is a VTP server, because we've done that in one of the earlier labs, whereas the middle one and the right hand one are VTP clients. So what we should be able to do is just create the VLAN on the VTP server, and it should just go across to the VTP clients. Okay, enable, privilege mode, configure terminal, global configuration mode, do show VLAN brief, abbreviated slightly, and we have no VLAN 100. Okay, do show VTP status, and this is a VTP server, so we're all good to go. How do we create a VLAN? We're already in configuration mode. It's VLAN 100, and you have created a VLAN. So simple. We'll name the VLAN. This is a lovely keyboard, but my fingers are not working properly on it today. VLAN 100, name voice. Okay, good. We'll exit there, and we'll run the command do show VLAN brief, just using the up arrow to find it. Do allows you to run any show command in any mode. Well, not just show commands, pretty much any command in any mode. Okay, and you can see we've created VLAN 100 now voice. There is no port in it though, and what we want to do is we want to put port fast Ethernet 01 into a voice VLAN of 100, but we don't want to take it out of the data VLAN of 10. So you do not, under any circumstances, go into the interface, so interface fast Ethernet 01, and type this command, switchport access VLAN 100. Do not do that. Do not do that, whatever you do, because that will switch it into a VLAN 100 basically for data. Okay, we want to leave this port in VLAN 10, which is where it is already for data, and we just want to put it also in a voice VLAN of VLAN 100. Now in order to do that, you type switchport voice VLAN 100. This leaves the data VLAN where it is in VLAN 10, but it puts an additional VLAN, voice VLAN of 100 on. Okay, effectively that port's now in 2 VLANs. It's kind of like, almost like a little mini trunk, but it's not really. It's in VLAN 10 for data and VLAN 100 for voice. So clever stuff. Okay, while we're in here, we'll just put spanning tree port fast. Port fast allows the port to come up very, very quickly. In fact, it's gone green very quickly there. Port fast, it bypasses some of the steps of spanning tree protocol. So you only really want to do this on ports that are connected to end devices, like switches. Sorry, not like switches, like PCs, laptops, IP phones, servers. You do not want to do this if the port is connected to another switch, because you'll create a bridging loop. Okay, we're good. So that one's done. We'll do a WR to save it, and just a bit more quickly now, we'll configure the other two. So, show VLAN brief. We should have VLAN 100. It was created on the server. This is a VTP client, so it's automatically been created on here. I didn't create it on this switch. VTP did that for me. We'll go into interface fast Ethernet 01. We'll say switch port voice VLAN 100. So in this case, fast Ethernet 01 is in a data VLAN 20. So switch port mode access switch port access VLAN 20 puts it in a data VLAN of 20, but it's also now in a voice VLAN of 100. Clever stuff. Spanning tree port fast. Lovely. WR. And finally, last switch. Enable show VLAN brief. Now fast Ethernet 01 is in VLAN 30, the management VLAN for data. We do have a voice VLAN because again this is a VTP client, so it automatically received that voice VLAN from the VTP server when we created it on the VTP server switch. We're going to interface fast Ethernet 01 and say you will need to be in a voice VLAN of 100. And by the way, spanning tree port fast, so make sure the port comes up nice and quick. No 50-second delay. Okay, excellent. You've probably seen that where you've plugged a device into a switch and it's sat orange there for quite some time. That's spanning tree, making sure that there's no layer 2 loops. Checking for bridge protocol data units. So spanning tree port fast sort of avoids most of that and brings the port up very quickly. Now that in fact is the VLAN done. So we have a separate voice VLAN now. Fast Ethernet 01 on all three switches is in a voice VLAN of 100. In addition to their normal data VLANs of 10, 20 and 30. Next step is on the router. Okay, now I've forgotten what the username and password is on this router, so I will use a little trick that you can do in Packet Tracer, but you obviously can't do it on a real router. If you go to the Config tab and go to Fast Ethernet 00, which is one of the interfaces, and then go back to the CLI tab, you'll notice it's now bypassed the password altogether. You can hit Ctrl Z and you're back in the router. So should you ever forget what your password is in Packet Tracer, that's a quick way of getting around it. Okay, next step, sub-interface for the voice subnet. So router on a stick commands again, interface fast Ethernet 00, the interface that leads down the trunk link to the switch. In fact, thinking about it, we don't want to go in interface fast Ethernet 00, do we? We want to create a sub-interface fast Ethernet 00.100. Sub-interface number matching the VLAN number. It doesn't have to, but it makes sense to, because it just makes it easier to understand when you're looking at the configuration. If your sub-interface number matches your VLAN number. But like I say, it doesn't actually have to. Okay, let's say encapsulation .1Q100. And this just turned around and basically says the packets that are going into fast Ethernet 00100. It'll inspect the frame and it'll have a little look at the VLAN tag, and if the VLAN tag's set to 100 then it needs to deal with it. Okay, so now we've done the encapsulation .1Q100, saying expect packets tagged with VLAN 100. We can put an IP address on. That IP address is the default gateway IP address up here, 192.168.55.254. So 192.168.55.254 with a /23 subnet mask. 8 bits, 8 bits and 7 bits. That'll be /23. That's looking good. No need to do a no shut because it's a sub interface. As long as the physical interface is up, the sub interface will be up. That's the sub interface created for the voice subnet. We're moving nice and quickly now. Exit. We'll create a DHCP pool. IP DHCP pool. Give it a name. Voice pool. Makes sense. Okay, it's just a name. Network. What network do we wish to allocate addresses from? What's the scope or the pool of addresses? 192.168.54.0 on a /23 mask. Okay, that's a lot of addresses actually. Yeah, 510 usable addresses minus the default gateway, 509 addresses. 2 full class C's worth. We want to say the default router, so as the clients get their default gateway addresses, the clients being the phones in this case. The default router is 192.168.55.254. Okay, that's good. We might just as well put the DNS server on here. Not that it makes any difference really on this particular design. What we do need, and this is slightly unusual, if you haven't done voice you wouldn't have seen this before, option 150 IP 192.168.55.254. The option 150 IP is the IP address on the interface of the router. And basically, option 150 means that when this router hands out an IP address and a subnet mask and a default gateway and the DNS server to the clients, when the clients request via DHCP those parameters, the router hands out those parameters. It will also hand out an option 150 of 192.168.55.254, and an option 150 specifies the IP address of the TFTP server. Because the phones are very dumb devices, they've got no real intelligence. You don't do a great deal of configuration on the phones. The phones do all of their control straight from the router. In addition, they may well need to download firmware files from the router, and they'll do this using a TFTP server that lives on the router. So this just hands out, together with all the other things that are normally handed out by DHCP, an option 150 TFTP server address, which is the router. Okay, that is that. Believe it or not, the DHC pool is configured. Show, run. Let's see what we've got. So there we go, there's a DHCP pool, IP DHCP pool, voice pool. Hand out an IP address in this range. Specify a default gateway address to the clients of the router interface, a TFTP server address of the router interface, and by the way, your default gateway lives here. So we're looking good. Okay, now comes telephony service. This is the really cool part. This is the nice part. Well, it's all nice because it's Cisco. Cisco's great, but this is really nice. So conft global configuration mode and telephony-service will drop you into telephony service. And once we're in there, we need to specify several things, one of them being our IP source address. So our IP source address is the address of the router that controls the phones. Cisco used to call it a call manager, or in the case of it running on a router it would be Call Manager Express, but now it's normally known as Cisco Unified Communications Manager, or if it's running on a router instead of a server, Cisco Unified Communications Manager Express. So let's see, your phone controller lives at 192.168.55.254, that's the router, and the port number is 2000. This is related to the signaling protocol. Most voice over IP systems use SIP, Session Initiation Protocol, which runs on UDP at the transport layer, UDP port 5060. Whereas Cisco phones don't use SIP, they use something called Skinny, or Skinny Client Control Protocol, SCCP. That uses TCP at the transport layer and runs on port 2000. Okay, so you do need to make sure you type in port 2000 on the end of whatever IP address you're using on your router. Okay, we need to specify how many phones we want, so max ePhones. This model of router can support anywhere between 1 and 42 phones. We only need 3, so that's good. Max DNs. DN is a directory number. effectively it's the phone number for the phone. So max DNs will have 3 phone numbers, one for each phone. So 3 phones, 3 phone numbers, one for each phone. And that's all we need to do about there. Number of phones, the number of directory numbers, and the IP source address, together with its port number of 2000. Now, slightly trickier part now. We need to configure the ePhones. So we'll say ePhone 1. I'm going to do this in a very specific way because it can become quite painful if you don't. ePhone 1, what have we got? We've got type, and this is a 7960, and actually I'm going to leave it at that. I'm literally just going to leave it at that for the moment. Okay, you'll probably see why in a little while. Okay, I'm going to wire that phone up. I'm going to wire the first phone up now. And to do that, I'm going to remove the cable from the switch and plug the cable in the PC port on the back of the phone. The phones have 2 ports on the back. In fact, if I click on the phone for a second, let's have a little look, move it across. There's more than 2 ports, but there's 2 really important ports, the ones with the yellow labels above them. And one of those ports will say switch, that goes off to the switch of course, and the other one says PC, and that goes off to the PC. So effectively the PC is daisy chained off the back of the phone. There's like a little mini switch in the back of the phone. If your switch supplies power over Ethernet, then it will actually power the phone as well as take phone data, but it will pass through to the PC. This way you only need to run one cable to the cubicle and it will drive the phone, and it will also work the PC, which is rather clever. Okay, now we need to get another Ethernet cable straight through Ethernet from fast Ethernet 01 into the switch. That's good, and we'll hit the fast forward button. Actually, that's not going to help, is it? I need to put power on the phone first. So how do we put power on the phone? Well, it's a power adapter. We just slide it up and plug it into the back of the phone. That's it. Okay, because we're using port fast, you'll notice that the light on the switch has gone green very quickly on fast Ethernet 01 on the switch. Because of spanning tree port fast, it's pretty much instantly gone into forwarding mode. Okay, that's looking good. And while we're here, actually, let's set up the number for this phone, the DN. How do we do that? ePhone DN 2001. Okay, that's not how we do that. ePhone DN 1. ePhone DN 1. Look at that. Number 2001. Slightly getting ahead of myself there I was. So ePhone DN 1, directory number 1, number 2001. This is your extension. Cool. Now we'll exit, and we'll try to put that directory number or phone number on ePhone 1. We do that by typing ePhone 1 button. On button 1 on the phone, we want to put DN or directory number 1. Now, if you try to do this the other way around, if you try to put button 1 colon 1 before you've created the ePhone DN, it will give you basically say no, you can't do that in a very rude fashion. So here we go. Oh, look at that. 2001, extension 2001. Excellent. Okay, so that's done. Let's sort the next phone out. So exit. ePhone 2. Type 7960. Exit. ePhone DN 2. Number 2002. Love it. Now we should be able to go back into the ePhone, ePhone 2, and say button 1 on the phone needs to connect to directory number 2 on the router, which is telephone number 2002. Need to configure the MAC address. I knew there was a reason I'd plugged the phone in. Okay, right, here we go. So, see what I mean about how fussy it is that you do things in the right order. So plug the PC into the PC port on the phone, get another Ethernet cable, take fast Ethernet 01, which has the voice VLAN of 100 configured on it, and plug that into the switch. Fast forward. Well, fast forward is not going to help because I need to put power on the phone first. So adapter on the phone. Superb. Now we can fast forward. I like that fast forward button. That's brilliant. Okay. Now, you'll notice it's not too happy at the moment. That's because it doesn't have the DN, the directory number, allocated to button 1. Button 1 is right at the top right hand side there. You can see the 6 buttons on the phone. Okay, it's just going to go round and round in circles at the moment like that until we allocate that directory number of, in this case 2002, to button 1 on the phone. Button 1 being the primary button. Okay, so let's do that. Wouldn't take it before. It wouldn't take it because it needed to have a ePhone MAC address configured, but by plugging in the phone it's going to have got a MAC address, so it should take it now. This is why I like to plug the phones in one at a time. Believe me, it's a lot less painful that way. Okay, so there's extension 2001. This should come up as extension 2002. Oh, look at that, extension 2002. I love it. Okay, and finally, exit ePhone 3, type of phone 7960, exit ePhone DN 3. You can actually see it creating the sort of ePhone interface. So when you type ePhone DN3, it actually creates an electronic interface. DSP, I think, stands for Digital Signal Processor, I believe. Yeah, it's clever stuff. Number 2003. Okay, exit. Now I won't make the mistake of trying to put the button on without the phone connected this time. So we'll connect the PC to the PC port on the phone. Another Ethernet cable, fast Ethernet 01, which is the only one that is in voice VLAN 100 on this switch, to the switch port on the phone. Put the power adapter into the back of the phone. A little fast forward there. Superb. Okay, then we need to go back into ePhone 3 and say button 1 on ePhone 3 connects to directory number 3, which is phone number 2003. Seems to be happy. WR. I've got a sneaky suspicion we're good to go. So let's have a little look. That's phone 2001. Let's phone between 2001 and 2003. Okay. Looking good. So how do we do that? We lift the handset, enter number 2001, ringing. You can see the light flashing. We're getting a from 2003 appearing on the phone. We pick up the phone, connected. Be nice if Cisco could make these actually ring, wouldn't it? Although I'd imagine in a class full of 20 students you probably don't want them all ringing. If we hang up, hangs up on this side. Great job. Let's try that the other way around, just for the hell of it. So pick the phone up, enter number 2003, ringing away, pick up, connected, close. Oh, superb. So this phone's working. Now you might notice something on those phones. Look at the date, 3rd of the 1st 93. Where is it getting that date from? The router. Let's just fix that for a second. Show clock Yeah, that's where it's getting the date from. So clock set. Notice you don't do this in global configuration mode. It's very odd like that. Okay, we want to put in the time, so we will say 16:59:00, and it is today, believe it or not, it's April Fool's Day today, so that is the 01 of April 2016. Superb. Now if I do a show clock, okay, what you should do on real phones, and it's probably exactly the same on Packet Tracer, you should now go into Telephony Service. After changing the date and time, you should type create CNF files, create configuration files. Okay, that's good. WR. Now, on real phones, you normally would reset the phone at this point just to make sure it gets the time and date very quickly, but these have done it straight away. So we've got 16:59 P for PM on the 4th of the 1st 2016. Oh, how good is that? Superb. I'm just going to try another little phone number here. Let's dial from 2002 to 2001 just to make sure that one works as well. Yep, ringing away. And there you go, phone's configured. Okay, so let's have a very quick look at their configuration. Show run. What did we do? We did create an IP DHCP pool for the voice subnet, specifying the normal things, the network that we're handing IP addresses out from, the default router, in other words the default gateway we're going to give the clients, the DNS server, also the option 150 code for TFTP. And what else did we do? I think the rest of it's probably going to come under ePhones, ePhone DNs and telephony service. There we go. Let's see if we can get most of that on one line. There we go. Yeah, we did. So telephony service, maximum number of ePhones, 3 phones, 3 directory numbers, 2001, 2002, 2003. Source address, being the router that controls the phones, on port 2000. TCP, that's Skinny Client Control Protocol. Phone number 1, phone number 2, phone number 3. See how it's registered the MAC addresses? This is why I plug them in one at a time. I mean, you can change the MAC addresses, but it can be quite painful at times, so it's just easier sometimes to plug them in one at a time. Button 1 on ePhone 1 connects to directory number 1, which is 2001, which is why this phone, ePhone 1, has a number of 2001. Of course, you can change these numbers around at will as well. So, and that is voice over IP configured. I hope you enjoyed the video, and tune in next time. We'll have a little look at configuring a site-to-site VPN.